Read code number 314, binary tree vertical order traversal. This is medium question. Let's get into it. Given a binary tree, return the vertical order traversal of its node values from top to bottom, column by column. If two nodes are in the same row and column, the order should be from left to right. Okay, let's check with example 1. First, we need to order sorting sequences first left to right, and then second is top to bottom, right? So in this case 9 is only 1, so 9, and then second is top to bottom, so 3, 15, so it's 27. So output is 9, 3, 50, 27. How you gonna do? Do you have an idea? Yes, okay. There are one question, implement level order with DFS, depth first search, not breadth first search. At the time, we use map, and then we make variable level. So while we traversing, we calculate the level. So you put to the map, and then level at the time, level is the key of map, and then value is node. So finally, we sorting by key of map level, and then put the same levels node. In this case, we also use this one, so we will gonna use map, and then we can solve the first order sequence. But how we solve the second sequence? In this case, top to bottom. Do you have any idea the traversal top to bottom? That's right. We will use level order. And then, okay, let's see. First, we will traverse the level order, and then put to the map. That's level. This one is quite similar of implement level order with DFS. Okay, let's implement the code. So first we need to output, and then need to map, and then I will use a default to dig because I would like to initialize with list. So collections and default digs and list, and then I needed queue, and then I will queue. I put the queue. I put root as tuple because we needed to level, and then initial level is 0. Okay, and then I will iteration until queue is empty. Range thanks queue, and then I will pop node and level from queue, and then okay, in this time we needed to put it to the map key is level node, and then okay, let's put the queue if node left exists, queue append as tuple node left, and then in this time left is level is decrease, right? And then right is increase. Does it make sense? So level -1 node, if node is right, queue append node right, and then level +1. Okay, now we finished to make map, and then we needed to find the start point and end point. In this case, okay, let me simulate this one. Let's think about only level. this one is labeled 0, and then this one is -1, this one is +1, this one is 0, and then this one is 2. In this case, if we getting from the smallest level to largest one, there are two ways. First is we are able to sorting by the level, but at this time complexity is, that's right, n log n, because the sorting needed to n log n. But if we decrease the maybe we just find the smallest level and then max level. If we find this one, we just iterate one time. Does it make sense? So I will use it, and then this just iteration, because time complexity is the linear, is better solution than using sort. So I will use that. Start is min of map keys, and then end is max map keys, and then I will in range start to end. Is it okay? No, we need to include this one, so +1. So I will output of pen one by one map I, then we can get smallest from smallest one to biggest one. That we can afford. Okay, let's check the code. Oops. Output is the node, but we need the value. So this one I put the node value change. Yes, looks good. Yeah, there are one edge case. Okay, let's check if its root is 0. This one okay, append this one okay, while Q. This one is the none, right? And the 0. And then putting level is okay, but if in this case node is null, so null that does not have the left property, so runtime error occur in this point. So how we gonna do? We will prevent edge case if root is none, just return none. Okay, great. Okay, in this time complexity is linear time, because it traverses only one time of all node, and then space complexity also the linear time, because map also use the same amount of count of node. Thank you.